One of these new electric buses right here, clean energy bus. Yeah, see? I can't wait for every single bus to be, zero emissions. Not only that, I can't wait for the electricity, most of it in New York, to come from hydro and or wind and solar. But hydro energy is very cheap. In fact, guess what state has one of the cheapest energy in the United States? It's Washington State. And guess where that energy comes from? It comes from hydro. Hydro is cheaper than coal. It's cheaper than natural gas. Well, it's actually about comparative to coal, but it is cheaper than natural gas, a lot cheaper. Hydro is actually, sometimes if you do hydro the right way, it could actually be even cheaper than coal. And not only that, it doesn't produce any emissions. It's water. I mean, yes, it does have some effect on the environment, downstream effects such as flooding, but other than that, it does not have any harmful effects on the environment. Although it has more local effects, and even those local effects are not that harmful. There's no waste. There's no toxic emissions. In fact, you could actually use in Washington State, they actually use the natural river flow. They don't even really dam stuff like they do in the Hoover Dam. It actually is more, they just set up a bunch of little small waterfall type dams, which is producing a ton of electricity without causing any harmful effects. They use the Columbia River to generate most of the electricity in Washington. And this is unbelievable, Seattle has one of the lowest energy rates in the world and in the United States, especially residential and commercial. It's about 20 to 30% lower than the national average. And yet, this energy comes from hydro. It doesn't even come from wind or solar or coal. So because of this, it is very likely that New York will do similar to the same thing. Not, of course, Niagara Falls is already doing it, but what I'm saying is, using the Atlantic Ocean, tidal energy has a huge amount of hydroelectric potential. If you use water to generate electricity, there's so much more power in the ocean than in rivers that it's unfathomable. Just 1 square kilometer of ocean water has many times the energy generating potential than than the same area in the river. Well, river is flowing fast, in a narrow area. In ocean, the flow is faster. Well, it's not faster, but it's more dense. Especially if you have deeper, if you put the turbine deeper in the ocean, and of course put nets around it so fish don't get in there, you could actually generate huge amounts of electricity without harming the ecosystem. And this way you could have 2 sources of energy from the ocean, from deep currents in the ocean, just the ocean moving, and more surface from the wave power. And this way you could generate vast quantities of electricity and not harm the environment in any shape, way, or form. Other than, birds might sit on it and maybe a little harder for them to get fish. But other than that, the effects are going to be very minimal, compared to ocean acidification. I mean, what we're doing right now to the planet is far worse, by using all this carbon. Because carbon in the ocean, when you combine carbon with H2O, with water, there's a chemical reaction that takes place that turns water and makes it more acidic. Carbon dioxide mixes with some of the other substances in the water, and it forms carbonic acid because it mixes with like some bicarbonate in the water, and that becomes carbonic acid. Carbonic acid eats away at the lining of shellfish shells. It's going to be harder for the bicarbonate to actually hold itself together because carbonic acid eats away at the bicarbonate, which is more alkaline, which has a higher pH. And because of that, their shells become more brittle and are not able to regain their form. And as a result, you will have, shellfish that are weaker, more susceptible to disease, and shellfish have a very important role in the ecosystem by filtering out all the bad stuff in the ocean. The bacteria, viruses, dirt, pollution. That is why consuming raw shellfish, of course, is not a good idea sometimes. And that is why in certain waters you're not supposed to eat shellfish, especially in populated and polluted areas. However, shellfish, while it is edible, can cause issues, especially if you eat large amounts. You can get ill from chemicals in the shellfish, or get a foodborne illness. You're more likely to get shellfish, mostly get sick from shellfish from food poisoning, from bacteria. That is why in Oyster Bay it's not a good idea to eat shellfish, because people while they don't dump human waste there anymore deliberately, there is still stormwater runoff that goes into Oyster Bay, in Long Island, and all that bacteria from human waste and from human waste gets into the shellfish. You could get human illnesses like E. coli. You get E. coli now from shellfish now, but that's our E. coli. It's kind of like we're basically, but that's how you get sick from shellfish. Of course, 200-300 years ago, that probably wouldn't have been such a problem. But after the Industrial Revolution, not only is human waste getting in there, which became a huge issue about 100 to 150 years ago, because the sewer systems were being dumped into the rivers of New York, where the shellfish are, but also toxic waste and pollution is also getting in the waters. And shellfish, I believe, filter that as well. And smaller fish eat that. And then the bigger fish eat that, and the bigger fish. That's why tuna, you can get mercury poisoning from eating too much tuna. But going back to what I'm talking about, this is why it's better to use wind and solar and hydro, because those forms of electricity have lower carbon emissions. In fact, back in 2013 and 2014, Tesla had this energy indicator, this carbon dioxide per mile, or how much CO2 you're producing from transportation. In Vermont, average car in America, or in Vermont or anywhere, is about 35.32 pounds of carbon dioxide per mile. However, in Vermont, it's 0.03 pounds per carbon dioxide. But you have to travel roughly 30 miles, because 0.03 times 10 will be 30, times 20 will be 60, times 30 will be 90. So you have to travel roughly 33.33333, miles to equate to 1 pound of carbon dioxide. So you could travel 33 miles on a Tesla Model S or electrical car in Vermont to get 1 pound of carbon dioxide, while a car will emit thousands of pounds, tons of carbon dioxide, while a Tesla will only emit roughly 1 pound. So you might emit close to a ton of carbon dioxide in a car, while only 1 pound for a Tesla Model S. So in Tesla, this is because of Yankee Candle, nuclear power plant. So 0.03 pounds per car per mile, while 35 for a car. So basically, it's a factor of, where it was a factor of 1,000, because 0.03 times 100 will only have been about, 100 times. Yeah. A regular car in the same amount as an electric car will, in electricity production, produce 1,000 or 100 times less. So it's like 35.32 pounds per mile for a regular car, gasoline car, and 300th of a pound for Tesla Model S, or Tesla. So if you do the math and you try to figure it out, you divide 0.03 times 100, you'll get to 30. And of course, you could tinker for hours to get the exact amount, or you can do, some calculus or, some algebra to figure it out, because we'll give you a more accurate amount in a short amount of time. And it's probably going to be in order. Okay, so it's going to be 0.03. So how much less is it going to be than 35.32? So by doing that, you do 35.32 divided by 100, which will be 0.0352. So it's going to be 0.0052. Multiply that by 100. And then you will get an answer close to about, multiply that by 100, and you get about roughly, 0.052 times 100. So you'll get about 52. 0.0052 times 100. So you're going to get about either 0.0052 times 100. Yeah, you're going to get about, I think I did the math wrong, but because, I'm trying to do it in my head, and that's why you're never supposed to do math in your head. You're always supposed to do it on paper. But basically, and math is not even my strong point either. So it's so it's going to be 35.32. Divide that by 100. Divide that by 10, it's going to be 3.52. And so for Tesla model, so it's going to be actually 0.352. So it's going to be 0.352. Well, Tesla's going to be 0.03. But so actually it is 1,000, almost 1,000. Look, 0.03 times 10 will be 0.3 times 10, which is 100 now. It's going to be 3.0 times another 10 is going to be 30. So yeah, it is 1,000 times 10 times is 100 times 10 is 1,000. So it's over 1,000 times less carbon dioxide per mile that the Tesla Model S will produce. And that 0.03 comes because 5% of the energy comes from wood burning. But now, unfortunately, now that Yankee Candle is no longer operational, of course that's changed. Now they're getting some energy from natural gas, which of course caused their carbon dioxide emissions to go up by a factor of about, I would say 100, because now I believe with electric cars in Vermont, it's going to be now 5 pounds per mile. So now it's going to be about times 100. It's going to be times about roughly 180. So 0.03 times 180 will get you to about 5 point something, which is about the amount I believe that is now in Vermont because of transitioning towards natural gas away from nuclear. But of course, in Washington State, in certain areas, all of your energy comes from hydro. So you can have zero tailpipe emissions and zero electric emissions, zero emissions into the environment. Tailpipe and factory emissions, electrical generation emissions will be zero in certain areas in Vermont. Washington State, because of hydro. So yes, this is about a 15-minute video that was caused by me seeing this electric bus. But if we can completely convert to electric transportation, all cars being electric, all vehicles being electric, of course, hopefully 20 years from now, we'll be using graphene, which is made from graphite. Hopefully we'll find a way to convert pure carbon into graphite, and the graphite into graphene. So you won't be even having to mine for anything. Hopefully 20 years will be like that. And through that, hopefully, there's no harm to the earth. There's no harm to the environment at all. This is not even fantasy that I'm talking about. This is actually real, something real. Because the coal that we mine, coal becomes graphite, and graphite becomes graphene. Scientists turn graphite into graphene. If they isolate the strands, the honeycomb pattern of the carbon. So technically, it's possible you could do this using solar energy and pressure to convert the carbon or the coal into graphite, and then the graphite through using nanotechnology into graphene. Then you could use that as batteries, and so on and so on. So coal, while considered to generate energy, if done the right way, can actually eliminate dependence on fossil fuels. No more using coal as cheap energy, but using it for something far better. And one lump of coal can produce so much energy, it is unfathomable. Well, not produce, but contain so much energy. So one piece of coal, one lump, can produce, well, not produce, but if turned into graphene, can charge in basically 1 minute and retain a charge for hours. Like it charge in seconds. And not only that, so it has a potential to be a super capacitor. So solar energy storage and storage from wind energy from nuclear can be insane. You'll never have to worry about energy storage again. And of course, this will have huge ramifications for the world, good ramifications. By ramifications, I'm talking about benefits, huge benefits. Coal miners may actually not be out of the job. They can continue to mine coal, yet it can be done the right way. We don't have to mine such huge amounts of it, and we don't have to shut down these mines, and we don't have to open up new ones either, because we can turn the coal into something much, much more valuable. Of course, you'll have to get all the particles out of the coal. Has to be pure carbon, because even the purest coal is about 90% carbon. So you'll have to process the coal, probably scrape the coal off, isolate the particles from the coal, try to make it more like 99 to 100% carbon. That might take some time and effort, and the payout is going to be so much more immense that I think it's worth it. But I believe most of our energy should come from renewables as well as molten salt reactors. Of course, Republicans are going to be against this because they are so entrenched by the fossil fuel industry. While coal mining will be a thing, you'll still have some coal mining going on because of that, but it's going to be very limited. And it's not going to be used for coal energy. So the coal miners, so it's going to be a win-win, I would say a win-win situation, because some of the coal miners who are no longer mining can actually get jobs in the renewable energy industry or in the molten salt reactor industry, because molten salt reactors don't require pressurization. and don't require coolant either. It's a very interesting reactor. I've talked about it a few years ago, and I still have a petition online for it. However, I don't think my petition is going to get anywhere, but I'm just trying to spread the awareness of molten salt reactors. And I'm usually spreading my petition on nuclear videos on YouTube, molten salt reactor videos, because I'm an environmentalist, and wind energy and solar energy alone are not going to solve the energy crisis. In fact, this reactor will consume waste. So it's beneficial to the environment because it consumes waste. It doesn't really produce. It does produce the waste, but it also consumes it. But it can also consume waste. It also is able to consume waste from reactors from today, so we don't have to store the waste or even transport it. You can also with molten salt reactors, not only consume waste, but produce so much more energy than regular pressurized water reactors. They're meltdown proof because they're not pressurized. If you lose pressurization in regular reactors, you're going to have a hydrogen, a explosion of steam, which will cause a hydrogen explosion or steam explosion, which can lead to a meltdown. Because the fuel is solid, it's not in a molten state. Because the fuel is solid. In a molten salt reactor, the fuel is already melted, so you're not worried about a meltdown because it's already in a meltdown state. You don't have to worry about the core melting either because there is no core. It works completely differently. Molten salt reactors and pressurized and regular standard nuclear reactors are they're two completely different animals. It's like saying it's like a species of cats and a species of dogs. Yes, they're mammals. The mammal being nuclear energy. One is one is more aggressive and the other is more relaxed. I don't know how to make a good comparison, but with molten salt reactors, you get high energy, no risk, basically, very little risk. There's no risk of a meltdown. There's no risk of an explosion. There's no risk of, because as soon as the material cools down, it solidifies immediately. Because there's no pressurization, there's no water, there is no radioactive materials to worry about. Even if the worst case scenario happens, say a saboteur sabotages the plant, you won't worry about all these materials escaping into the environment because there's no water to worry about. The only thing the water is used for is steam to turn the turbines. The water is not used for pressurization, it's not used for cooling at all. In fact, this reactor is so safe that even if it has a failure, say somebody sabotages the reactor and some of the nuclear fuel actually escapes from it, which is almost impossible the way it's designed, you will not have a meltdown and the material will solidify. The only stuff that will be released will be X-rays, and that's over a short area. You won't have to worry about all these radioactive areas falling over a wide area. You'll have X-rays over a short parameter around the reactor. That's about it. And that's the good thing about molten salt reactors. And the only way the fuel can actually get out of the reactor if a person deliberately puts it there, which is impossible. Which is almost impossible the way the reactor is built. And even in the worst case scenario, which I just said, it's not even terrible. But Fukushima, Chernobyl, they're horrible because that was also the worst case scenario. But guess how many people died from both of these accidents? Chernobyl and Fukushima combined has not even killed 50,000 people combined. Yet every single year, 3.5 million die every year from fossil fuel power plants. In fact, hydro energy, which has almost no environmental consequences, no pollution, has killed far more people than nuclear energy because of dam failures. In fact, globally in the last 20, 30 years, close to 700,000 people have died from dam failures. So here's carbon, go way off the charts because every year 3 million people die, 3.5 million. Water, which kills about a few 100,000, and nuclear, which is all the way down here. But it has the potential to be more dangerous. Of course, if it's used as a weapon or if you have like every nuclear reactor explodes, I don't know. But guess what killed more people than hydro energy? Believe it or not, renewables. Because of the production of solar panels, it's actually bad for their health as well. But, however, it's because of the production. It's the workers who are at risk. But, of course, millions have not died from. Actually, here's it. So it's first is carbon, coal, natural gas. Well, of course, coal is the main contributor. Then it's hydro, renewables, and then nuclear. The reason so few people die from nuclear energy is because of how well it's regulated. And like France, I think nuclear energy, even the molten salt reactors, should be regulated by the federal government to ensure absolute maximum safety. Guess how many nuclear accidents France has had? None. Zero. Of course, the Soviet Union was an exception. People there decided, oh, you know what? We're not gonna do this test the right way. We're gonna do it not the way we're supposed to. That's why you had a meltdown because it was human error. But after Chernobyl, there's better understanding of how dangerous it is if it's done the wrong way, and because of that, you don't have any more accidents. But molten salt reactors are not dangerous, so if it's done the right way, the benefit to the planet will be immense, and especially to humanity. Cheaper electricity than coal, cheaper than hydro, and you won't have to dam up rivers either. So it's a really good thing. And guess what? It's from thorium. Thorium is found everywhere. Thorium is found on the moon. Thorium is found on every body in the solar system because thorium has a half-life of 6.5 billion years because it's so inert. In fact, thorium is actually one of the most common elements in the Earth's crust, almost as common as lead. The next common element after lead is thorium. It is 4 to 5 times more. It's about 4.5 times more common than uranium in the Earth's crust. And of course, in a reactor, after you have to first turn the uranium into thorium into uranium 233. Well, 233. It takes about a month to produce, and it takes a good amount of energy for the thorium 232 to become uranium. But the energy you get back, the returns, are so much greater than the energy input required. But the reason it wasn't done, despite all the overwhelming benefits, is because Nixon axed the program because he wanted to pursue nuclear weapons. He realized that thorium was not practical in nuclear weapon production for 2 reasons. Uranium-233 would produce much more gamma rays than uranium-235, which will it would mess up the electronics of a nuclear bomb. That's the first thing. The second thing is, it didn't produce plutonium-239 or 238, which is the